AP Calculus BC, Unit 6, Day 8, Office Hours. It's multiple choice packet worksheet. Answers are at the top. Check your answers real quick. Pause the video if you need to. Okay, I'm going to go ahead and go on now. So let's see. Which of the following is the equation for dy dx? Whose slope field shown below? So I mean, I'd be looking for like zero slopes. Zero slopes. This is when y equals 0, which would be horizontal line equals 0, which I don't think that looks like it. It looks like it has 0 slopes, maybe around here, around here, around here. And then it looks like it kind of blows up over here. When does this equal 0? Well, that would be it never equals 0. When does this equal 0? Well, that would be when x equals 0 plus pi k. And you might look at this and be, oh, that looks like a trig curve. Well, you might have an idea because the antiderivative of this is negative cosine. I don't know, maybe when is this one equals 0? X equals plus or minus 3. That one seems promising. When is this one equals 0? Factor out of 3x. So this is going to be when x equals 0 and x equals 3. So I'm looking at, I don't think it's going to be that one. I think it's possibly, I don't know. Let's see. Well, oh, wait, I messed up. This is x squared. So this would be x equals plus or minus the square root of 3. So that one might be in now. It looks like they're at 0. This one actually seems to make the most sense. I mean, this one looks close, but the y would be negative. The y would be negative cosine, and this doesn't look like a negative cosine curve. I mean, it kind of looks like a cosine curve, but not a negative cosine curve. I mean, that's the other thing is we could always work backwards. Y, this one would be a cubic, right? And that doesn't look like a cubic. This would be exponential. That doesn't look like an exponential. This would, so I think I'm going to go with E. Seems to look the best. Okay, number 2, the figure below shows part of a slope field for differential equation, second quadrant. Based on the figure, which statement appears to be true as x approaches 0 from the left? So this is 0 from the left. Y increases without bound. It blows up. It does seem to go to like a vertical asymptote. As x decreases without bound, that's going to negative infinity. Y decreases without bound. No, I would say y approaches 0, approaches a horizontal asymptote. It doesn't go to negative infinity. They're saying decreases without bound means goes to negative infinity, but I don't think that's true. For all points in the second quadrant, the derivative appears to be positive or 0. That does seem to be true. So I'd say 1 and 3. 1 and 3. Okay. So we got some solving differential equation problems. So we are going to separate the variables and integrate both sides. And so then we get y squared over 2 equals x squared over 2 plus c. Now I'm looking at the answers. They all seem to be kind of written in the form of like a conic section. So I'll keep that in mind. I'm probably going to go multiply everything by 2. And you can do that now or later. If you do that now, you could still just call this C. And then you can plug in the initial condition. And so you get 16 equals 9 plus C. So C equals 7. So I think I'm going to move. Well, I mean, we just plug back in first. Um, but I think that, well, I mean, we could subtract the x squared to the other side, and then the 7 stays positive, which, and that's that's the equation of hyperbola. Usually we divide by 7 and put a 1 there. But I would say that, I mean, is this one on there? No, it's not quite on there. So we could divide it, we can multiply both sides by negative, and that one is answer A. So sometimes you have to manipulate your answers. Next one, separate the variables, integrate both sides, natural log the absolute value of y, we'll sine x plus c, we use the initial condition, plug 0 in, that's going to be 0, so c equals natural log of 3, so natural log of the absolute value of y equals sine x plus natural log of 3. We're going to exponentiate both sides, use rules of exponents to break this up. And I'm going to break this up. E the natural log of 3. So that'll just give you 3. To get rid of the absolute values, you do plus or minus. And then we should pick the positive and negative. You plug in 0, you should get positive 3. So we're going to go with positive. Now, technically, you would then need to do the domain, but because this is multiple choice, we'll not worry about. Plus, I don't think there are any domain issues. The last one definitely have domain issues, but it's multiple choice, so we'll give ourselves a break. Okay. Number 5, separate the variables. Integrate both sides. Natural log the absolute value of y equals e the x plus c. Plug in the initial condition. C equals natural log of 3 minus 1. So I'm going to rewrite it. Natural log of the absolute value of y equals e to the x plus natural log of 3 minus 1. I'm going to exponentiate both sides. Use rules of exponents, plus or minus. So this is going to pop in front as a 3, and it's going to be e to the x minus 1. Okay, so it's going to be the positive because e to 0 is 1 minus 1, e to 0 is 1. Positive. I'm not going to worry about domain, even though I think the domain's all reals. So we're looking for 3. Now we have to realize none of these answers look like that. So it might be also 3e to the x times e to the negative 1, which would be 3e to the e to the x over e to the 1. 3e to the e to the e to the x d. So that was a little interesting. Okay. Number 6, we're going to use Euler's method. By the way, you wouldn't be able to solve this anyways. Can't separate the variables. But, we could use the table approach. Y minus y old equals m times x minus x old, right? Y new, x new. This is your delta x. This is y prime at old. So y new equals y old plus y prime old times delta x. So you got to be able to go through that to even make use of this table because you got to know what you're doing. So we're starting at 1, 3, and we want to do step size of 1 to estimate y2. This is essentially just a single tangent line approximation. Now the table is becoming even less useful. I mean, whatever, we'll just stick with it. Step size of 1. If you plug in 1 and 3 in here, you get 1 times 3 is 3, minus 9 is negative 6. It's going to be this plus this times this plus this times this. It's going to be negative 3. But we could have just done a single tangent line, essentially. Number 7, the rate of decay of radioactive substance is proportional to the amount of substance present. So this is exponential growth decay. Y equals y naught e to the kt. 4 years ago, there were 12 grams. 12 grams 4 years ago. Now there are 8 grams. So we'll call this year 0. So we'll say y naught equals 12. Y equals y naught e to the kt. Now there's 8. There was 4. There was 12. And this is in 4 years. It's gone from 12 to 4. So we'll solve it. That's going to be 2/3. And how many grams will there be 8 years from now? So it's kind of another way we do this, but it's sort of a little trick. So this is the K value. So we could rewrite it y equals 12 e to the natural log of 2/3 over 4t. It says how many will be 8 years from now? Well, we're going to plug 12 in because this was 4 years ago. This is 8 years from now. So we're going to plug 12 in. I'll give you 3. So I'll bring it inside as a power. So we can use logarithms to cancel that out. So we reduce this, divide a 3 out, 32/9. So I think that's our answer, 32/9. Now the trick would be if in 4 years we ended up with 8 of 12, which is 2/3, then another 4 years we get 2/3. So this was 2/3 of 12. Another 4 years it'd be 2/3 of 8, because you get 8. And another 4 years would be 2/3 of that, which would be 16/3, and you would get 32/9, right? Because it just keeps going the same amount. Okay, a few more. Okay, number 8, population grows according to the equation. T is measured in years. This population will approach a limiting value as time goes on. During which year will the population reach half of its limiting value? So, I mean, it kind of logistic. It says this population will approach a limiting value. Well, let's find the limiting value. See if we can do it. I feel like these are positive exponents. So as t goes infinity, this is going to go to 0. So it's going to approach 6,000. Okay. So it says, during which year will the population reach half of it? Well, we just got to set the population equal to half of it. So it's going to be 3,000 equals 6,000 minus 5,500 e to the negative 0.159t. So we could try and solve this. Just doing the algebra. 0, 0. I'm going to flip both sides because this is in the denominator as a positive exponent. I think it's going to be easier to make it a negative positive exponent. So we take 5 out of this, 11 over 6. I'm flipping it so I can flip this side. And then we take the natural log of both sides. And we can divide by 0.159. So the only need for a calculator is to try and figure out what this number is. So natural log of 11 over 6 divided by 0.159 is 3.812. So it says during which year? During the 3 years have already passed. This is during the 4th year. So you got to understand sort of the wording of it too. That's during the 4th year. 3rd year is already done. 3 complete years have passed. Okay, so during the 4th year. Okay, solution to differential equation, Euler's method. Okay, so I'll see if I can set up table. Y new minus y old equals y prime at old, x new minus x old. This is delta x. So y new equals y old plus y prime old delta x. A table x y prime delta x. We're starting at 3, negative 2, and we're going to use delta x of negative 0.3 because we're going backwards to 2.7. Again, this isn't even Euler's method so much. It's just it's Euler's method with one step. So whatever. So it's going to be this plus this times this. So we got to just figure out what the derivative is. So we plug these in and we get negative 9 over negative 2 is going to be 9 halves, positive 9 halves. This is negative 3/10. So it's going to be negative 2 minus 27 20ths. And this would be negative 40. So it would be negative 67 20ths, or negative 3 7/20, or negative 3.35. All right, and we'll do it again. Let's see. X, y prime, delta x. We're starting at 3, negative 2. Be careful. X first, y second. This plus this times this. We're using trying the approximate value of 3.2. Now they're not really telling us what the step size is, so I guess we'll just go with the step size of 0.2 and see what happens. So we're going to plug in, see, 3 minus this is going to be 5 over negative 4, right? It's going to be that plus that times that. This is 2/10. So that would be, I'm just reducing it. It's going to be negative 1/4. It's going to be negative 2 1/4. Negative 2.25. There you go. All right.